right, students. So let us discuss problems of paper 1 first. So just let me know which questions we want to discuss, and then I'll show you the question on the screen, and then on a green screen I will scribble the solution for the question along with the concept. Right? So tell me, in paper 1, what is the first doubt all of you are having? Any concern, any doubt, conceptual issue in paper 1? Am I audible to all the students?
Yes, sir.
No, none of you have any concerns in paper 1? Should I skip the paper then and go to paper 2, or any doubt to any student? Okay, I don't think any student has any concern in paper
Yes,
1.
17.
Question number 17.
Yes.
Okay. Let me.
The second one also.
So let me just first take question number 17 as asked by someone. Just give me a moment. Let me open question number. Yeah, I'll give you a very straightforward method to solve this question. Question says there is a system of block, spring and pulley. You can see the arrangement. Spring and pulley are given to be ideal, and surface below is smooth. The only concern was what is the time period of small oscillation. That is what we have to find out. What I'll do is, while solving this 17th question, I will simply try to write the force which is going to change after the small oscillation. So I know all the forces like weight, extensions of the spring, whatever, tension, everything was balanced in the initial state. So let's think in terms of the general state after a displacement of x. So I will just draw 3 things. I will say additional force applied by the spring will be some kx. Now understand this thing, that I'm talking in terms of the additional forces, right? So that will be kx. Additional tension will act in the downward direction. Let's call that as delta t. So I'm saying with respect to the initial state, by displacement of the block of mass small m here, which is kept on the inclined plane, there is additional force because of spring and there is additional tension. I'm not interested in mg cos theta normal reaction, they're all cancelling out. And at this state, let the acceleration be a. Remember, the guy who is hanging here, another guy, m mass, on this guy, the additional tension vertically upwards will be delta t by 2. Look into the constraint relation. If you look into the data here, there was this string which was connected to a pulley, then pulley as such, one end was fixed, one end was going as such here. So I directly said if additional tension here is delta t, additional tension in these two will be delta t by 2. So the direct impact will be delta t by 2. Now my life is simple. Like if this is delta t kx a, now I said the acceleration of this guy by constraint relation is 2a. So only write the equation for these two people, you'll get your answer in one step. What you can say for this guy is delta t minus kx will be equal to his mass into acceleration, ma. And if you look into this person, it is minus delta t by 2. I've taken upward direction as negative. That is equal to mass m multiplied by 2. Now, if I solve these two equations, I'll get, I eliminate delta t, I get minus kx is equal to 5ma, and I'm done. Because basically, a comes out as minus k by 5m multiplied by x. So I got this term as my angular frequency square. So I think the question was, what is the time period? So, you know, time period will be equal to like 2 pi by omega. and omega is root of k by 5m. So everything was in place, he'll get the answer. The idea to solve the problem is a student should think in terms of additional forces in the general state. He should not bother about the mean position. He should not think about anything else. Energy method can also be used, but it is a lengthy method to solve the problem. If I was solving this paper in JEE, I would have solved in one line. Extra force, extra tension, constant forces are of no use. Extra tension, again, I have neglected the constant force because the acceleration in this state, general state, will be dependent on those extra forces, because like the constant forces will again cancel out. And then I've used a constraint relation, because if the tension becomes half, the acceleration will be twice. All those things you know, and you'll get the answer. Next question.
Second and third.
Second and third. Second was a conceptual problem. Second said, I'll make the diagram. Second was like this. If you look into the data carefully.
Sir, once can you go to previous screen? I'll take screenshots.
Yash, I did not got you. What do you want to say, Yash?
Sir, can you go to the, yes sir.
I'm not able to understand what he is trying to say.
Yes sir, next question sir. I
Okay,
just wanted to take screenshot.
Okay. Right. So fine. In this question, what the concern was, the concern is the charge is kept at the point a comma 2a comma a by 2. What I'm saying is, if you practically observe a cube, this charge is positioned at the center of the cube with those coordinates which are given for the right angle triangle acting like this. If I draw it carefully, the point is somewhere here in 3D, and the coordinates which have been given to you are somewhat like this. So I'll mention the coordinates also here. The triangular coordinates that he has given is A, 2A, and 0. The second coordinate he has given is 3A by 2. I think if you observe carefully, you'll understand what I'm saying. And the third coordinate was 3A by 2, 5A by 2, comma 0. Observe the area through which he wants the flux of this charge. And this charge plus Q is basically positioned at a distance A by 2 outward from this point. So I thought that if you make a cube of edge length A, and with respect to this room, you go to the center of the cube, then on the face which is there, the face which has been drawn on the board, on that face, you can draw a right angle triangle from the corner, and you have to find out the flux because of this guy through this. Now look into the symmetry of the problem. Now because of that charge Q, the total flux which is coming out of the cube is Q by 6 epsilon naught. So out of total, I took flux 1 by 6 first, that is going through that face. Then out of the flux which is going through the face, you can by symmetry say that we have got 8 right angle triangles. Observe it carefully. It's like this right angle triangle, the second right angle triangle, the third right angle triangle, and the fourth. Look into this. This is first, second. We're talking about this one as third, and this one as fourth, and four on the lower sides also. Now I'm saying across all 8 of them, the flux is same. So I've taken a factor of 1 by 8. So total flux through one face, and out of one face, you take 8 equal right angle triangle, because every right angle triangle that you are observing is symmetric in nature. Just observe, if this is the right angle triangle, I'm sitting here, I'm calculating flux through this, or you are sitting in front of this second edge and you're calculating flux. So whenever you're writing the flux out of these angles like 45, 45, 90 in 3 dimensions, either you are sitting in front of this point or the front of other point. And in both the cases by symmetry, the circular symmetry, the flux will remain the same. So directly I have taken a factor of 1 by 8. So your answer will be 48. Third was interesting. Third question. Third said that a tire is in a state of pure rolling. It is moving on a table. And he said the center of mass is having an acceleration of A what is the radius of curvature of trajectory of point A? Now the concept is, if the center of mass is moving forward with V and omega and A and alpha, you are saying, tell me the radius of curvature of point A. The concept is simple. You go to point A, find out the velocity of point A from the frame of reference of Earth. So I said, from the concept of ICOR, which is somewhere here, the velocity of this point is perpendicular to this line. So this is r root 2. This velocity is r root 2 omega. And we understand that this angle is 90 and all these angles are 45 each. They're 45 each. So the second thing that I should have done is, I should have calculated the acceleration of this point net, and then I should have resolved the acceleration in directions perpendicular and along the velocity. And whatever is the acceleration along the velocity, that will be equal to speed square. So I'm searching for that acceleration, which is perpendicular to the velocity, so that I can call this person as r root 2 omega, the net speed square upon radius of curvature. And radius of curvature is my answer if I can write this acceleration properly. Now tell me, if I go to point A and ask him, what are the accelerations you are having? This guy A will say, I have a centripetal acceleration which is omega square into r. He has got a acceleration because of center of mass, which is A. And then he has one more acceleration, which is the tangential acceleration, r alpha. And because this is in a state of pure rolling, we know that A is equal to r alpha and B is equal to r omega whenever required. Now do one thing. The three white color vectors that I have drawn, take their components on this line. So you can directly say this guy are equal. They are already like A root 2 in this direction. Right? So that A root 2 is immaterial now because it is already along this direction. So I'm not interested in A root 2. Now think about omega square r and resolve it. Right? So there will be one component like omega square r into 1 by root 2. And then there will be this guy, which is omega square r into 1 by root 2. This A root 2 and this guy will give me a net tangential acceleration. And what was required was omega square r into 1 by root 2. So 1 by root 2. This is what is required. I think it is simple. Omega square will cancel and you'll get radius of curvature. Next.
18th one, sir.
18th, okay. All right. 18th, what I should have done is, immediately what I will do, as you give me this system, initial state of charges I'll draw, and so what will happen is, there is a charge which is kept at the center initially. Then he says, another charge Q is given to S1 and minus Q to S2. So this guy is given a Q charge, this guy is given a minus Q charge. So in the initial state, if I look into the distribution, it is like Q minus Q. Here I'll have a charge of 2Q. Here I'll have a charge of minus 2Q. And here I will have a charge of Q. I've just shown the distribution in the initial state. Now, this was not required. His question was, as you close the switch, what is the amount of energy generated? So I just found out the distribution of charge so that I happily enjoy my problem. Now, if he closes the switch, what happens? So I will directly say that this plus Q minus Q will remain as such, right? Because of Gauss law. So this Q will remain as such, this minus Q will remain as such, but nothing can sit here and here. So indirectly, you can say that these guys neutralize each other, 2Q minus 2Q, and Q remains here. It is as good as saying that there are infinite rods, conducting rods which you have connected. So these two charges will neutralize each other. So this is the final state. So now the question is, what is the amount of heat generated? So my answer is initial potential energy minus the final potential energy. Initial and final, I should write all the possible energies, self energies and mutual. Observe one thing carefully. In the initial state, I have a point charge. In the initial state, these two guys club to a charge, which is minus Q. Here it is plus Q. And in the third state, in the initial state, this guy was having a charge of minus Q. Now it is having a charge of plus Q. So I'm directly saying that self energy in the initial state and final state is equal. So I'm not even bothered about writing the self energy. The only difference is the polarity. But polarity of charge on a shell is not going to change its self energy. So self energy is going to cancel out. Forget it. Not think about mutual. So what are the mutual combinations you are having? So I will write 3 mutual and their corresponding final. If initially equal to Q. This guy is 2Q minus Q, Q. So initial is K, Q, Q upon the radius, and that radius was R. This, because these two charges can be taken together as Q. And in the final state, this is K, Q minus Q. So K, Q minus Q divided by R. This is the change in the mutual energy of the first combination. Then take the combination of central charge with the outermost shell. Its initial energy is K into Q into minus Q, the total minus Q divided by that radius was 2R. And in the final state, that is K. Now, this outermost guy is having 0 Q Q. So K Q Q divided by twice of R. And similarly, you can write the third term. And third term is the interaction between the two shells, interaction energy. So it will be K, the product of the charges. So this guy was having Q, this guy was having minus Q. So it is basically Q into minus Q. You understand that that term will cancel out because outer radius is 2R. And finally, even if you write, it is basically K minus Q Q. So minus Q Q divided by outer radius 2R. So looking into the problem, I was not even interested in this. I knew that this will cancel out. Then you have to write the mutual interaction energy of two shells, and they are concentric, and the distribution is spherically symmetric. It is K into Q upon the radius of the outer shell. So that term will cancel out. So if you now open up the bracket and solve this part, you will get your perfect answer. That is how we'll get the answer. Next.
So question 14, option B.
Question 14th, I suppose. Yeah. 14th was nice. If you observe a unique pattern, the thing is, they have kept like this. They say there are two bars which are mutually displaced by a distance of L0, and both the guys are given an initial velocity of u in the rightward direction. So like this is rightward u, this is rightward u. The lower one is kept on a frictionless horizontal surface, and between the two bodies, you've got a friction coefficient which is equal to mu. Now, if you crack the motion, like what is going to happen basically? Till the upper one collides with the wall, friction won't get activated and both of them will move with the same velocity u. Now, after the collision happens, from that stage, this guy starts moving left with you at that very instance, and our lower guy is still moving with the velocity of u rightward. Now there will be a friction, a kinetic friction acting between both of them. So the upper guy, basically they can cross each other at a distance of L by 2 each. Now this distance here is L0. So L0 by 2 he will move forward, and the upper guy will move L0 by 2 leftward. Remember, after this stage, the center of mass cannot move. So what I need to find out is, the question is, what will be the final velocities? So the first thing is, if both of them move by L0, I will take some supposition. So net work done by kinetic friction will be minus mu mg L0. Remember, it is basically minus mu mg L0 by 2 and minus mu mg L0 by 2. And if they reach that state as such by decreasing speeds, both of them are decreasing their speed. So whatever is the negative work done by this guy, that should be equal to whatever is the change in kinetic energy. So under a supposition, I try to write the change in kinetic energy, which is finally, if it is 0, minus twice of half mu square. I am trying to derive an inequality. So just focus on what I am saying. I said I was moving forward with you. My friend was coming backward with you. Now when we will rub, whatever is the decrease of this guy, the same is the decrease in velocity of this guy. Because the center of mass is at rest. And both of them are having equal mass. The speed of both of them is reducing. He is moving backward with decreasing speed. He is moving forward with decreasing speed. If both of them move L0 by 2, L0 by 2, this is the network done. If supposition is, if when they overlap perfectly, if the speed of both of them becomes 0 at that instance, then this equation is valid. If this happens, then my u comes out as root of mu g L0. That means if my initial speed is root of mu g L0, both of us will come to rest together, and V will be at a distance of L0 by 2 from the wall. So B option obviously in the problem is correct. The final velocity will be this. Second thing. Now, the second thing that can happen is there is a possibility that the lower one keeps on moving forward, upper one keeps on moving backward, and they don't stop. If they will stop, both of them will stop. If they stop, both of them will stop together while crossing. If they don't, then the collision will happen again. If the collision happens again, then at that moment, for collision to happen, if the lower one is having a velocity of V, the upper one will have the same velocity V in the leftward direction. And can we find out that value of V with which they are going to collide? Yes, we can. For that, I should write an equation. Change in kinetic energy is twice of half m final speed V square minus initial speed U square is minus 2 mu mg L naught. Try to observe what I have written here. Try to observe what I have written here. I say if the collision happens, the lower guy hits the wall and he doesn't stop. The upper guy also doesn't stop. In that case, the change of kinetic energy of the lower guy and the upper guy is the same. And that is the work done by the friction on both of them from the frame of reference of Earth. So on the lower guy, the work done is minus mu mg L naught. Upper guy also the same. From this equation, I'll try to find out the condition on V. So if I solve this, my V comes out as root of U square minus 2 mu g L naught. This is the speed with which they are going to hit. Now the point is, if the speed is non-zero, then definitely the impact will happen. If it is zero, previously they would have stopped, right? Or if the impact happens, now the problem is simple, because as the impact happens, the lower one hits with a velocity of V. The upper one already has some velocity V. As the impact happens, immediately he will change the direction, he will become V left, and then they are bound to move together. Because after that, the relative motion is going to stop. So as far as the question is concerned, this much analysis was sufficient because you got the hold of problem. Now read the problem. First, the final velocities of both the bars will be the same after long time. There is no issue in that because that is always true. Either both of them will stop together, so final velocity is 0, or if they don't stop, the impact happens. If the impact happens, they will invert, and then both of them will move with a common velocity. So that is bound to happen. A and B are correct. C, the final velocities of both the bars will be 0 if U was equal to root of 2 mu g L naught. You can check that in this case, the final velocity will be 0 because C option is a very special case when at the moment of impact only the velocity becomes 0. So when they are just colliding, the velocity is 0. And if it is 0 for the lower guy, it is 0 for the upper guy also. So C option is correct. And B I have already analyzed. What about D now? The final velocities of both the bars will be this if U is equal to. Now, let me put it this way. To substitute the value of U, root of 4 mu g L naught, that's what they have given. So your answer comes out as root of 2 mu g L naught. The idea to solve the problem was only this much, that both of them are moving in the same direction. Upper one collides. Now they are moving in the inverted direction. So there's a possibility that both of them stop together. For that, we have solved the problem. Otherwise, they are going to hit. Otherwise, the lower one is going to hit. The lower one is going to hit. For that, I have written an equation here. This V should be greater than or equal to 0. And if it hits, then the problem is over. Because if it hits, then it inverts. And then both of them will move with a common velocity of V. Remember, after the collision of the upper guy, when this movement was happening, the center of mass was in a state of rest. So when they were crossing in the opposite direction, the center of mass was in a state of rest. And afterwards, again, center of mass will start moving in a common direction because of the impulse provided by the wall. So when they were moving in the crisscross direction, both of them were having the same speeds always, and their decrease in momentum was equal. I definitely use this fact while solving the problem. So now it is simple. Next problem. In paper 1. Yeah, Vamshika, which question?
Fifth questions.
Fifth question. All right, all right, all right. Fifth was again very interestingly put up question. The question was somewhat like this, that there are two rods. Like in basically these are two positions of the same rod, and it is hinged about the horizontal axis which is passing from this point. And this guy is being oscillated with an angular velocity of 2 pi by 3. I'll use this fact. What is basically happening? It's the problem is like this. If I've got a rod like this bottle of water, this is my rod here, right? So at this moment, there is an impact between a ball and the rod. So it gives an impulse to the ball. So ball now goes back in a projectile path. And as the ball is going there, this guy go like this, come back here. So at the very instance when he reaches here, our friend goes like this and says, again, I'll give you impact. So he reaches here by the same speed. He again gets an impulse. He goes back. So when he is going back, this guy again, when he is going back, this guy again comes from the downside, and the impact happens, and the impact happens, and the impact happens. So now enjoy the problem. So we understand that the time, a lot of things are very clear in this problem. Homogeneous bar, and there is a motor. There is a motor which is governing this motion with a uniform rate, right? So his angular speed is not constant on its own. It's being maintained by a motor. So now what is the question? Angular velocity is 2 pi by 3 radian per second. The time period of the periodic motion of the ball, the time period of the periodic motion is 2 seconds. So the ball takes 1 second to reach here. And right now everything is aligned. He takes 1 second to reach here. He also takes 1 second to reach here. And vice versa. So because he is moving with 2 pi by 3 radian per second, that means this angle is 120 degree. So he covers 120 degree, right, in 1 second, and then 120 in 1. So the ball comes back. Time period is given. Now the velocity at the highest point is to be calculated. Now everything is very clear, evident. Like if I take this angle, the net angle which is being given to me, I will try to find out this theta here, this 90 minus theta here, and I'll use all the equations now. U is known, the impact velocity here will also be equal to U. Now substitute all the data which is given and check what is the result you are getting. So when we observe carefully, we get that the angles which are coming out, theta which is coming out was coming out as 60. Just check this information carefully. Because then if it moves like this, impact happens, and this carries on, just check the angle which has been given. Once I know that, then it is a simple projectile motion problem. But data need to be verified. What is the information given accordingly? Let me read again. Horizontal bar rotates uniformly in alternating directions to and fro, while a ball of mass m bounces between the ends. The angular velocity of the bar is 120. So like 120 it is given. The time period of periodic motion of ball is 2 seconds. So that should be 1 second here. He should also take 1 second here, and then 1 here, and so on and so forth.
Sir, that
It's also
hopefully,
possible, let me put it this way. It is also possible that can be integral multiple. So it can be 240 also. And because this is possible that it is moving like this. So
So
when
240 is this angle, 120 is that between
Sir,
those two rods.
Yes,
that's what
sir.
I'm explaining. I'll come to that data. Technically, it can happen that he reaches here. But if you look into the physical geometry of the problem, mathematically, all the integral multiples I will think of. Because if I am moving with 120, let the ball come here, let the ball go there, let the ball again come here. And that is a possibility that I reach there. When I reach this position, it is possible that the impact has happened, right? For the ball to have the second impact, it is possible that I oscillate fast and I reach here again. You're getting a point. It is not mandatory that in the first collision only he reaches here. There's a possibility that he can go there, he can come back, And he again reaches by the time the ball reaches here. Because he has never said the minimum time period wali baat. He has never said that minimum term. So that is where the catch should be. So the language of the problem should be appropriate. Otherwise, taking the angle won't be absolute. You're getting my point, what I'm trying to explain. Just observe the question carefully.
Collision will happen with other end of rod, not with the same end.
Yes, sir.
What are you saying? Collision will happen?
With the other end of rod, not with the same end both times.
Yeah, that's what I'm saying. I have given all the possible angles. Now I'm saying, if you presume that that is for the first consecutive collision only. You got my point?
We are rotating complete rods.
If I have to just write the solution, directly I can say what has happened is, you have taken, that is just the solution. I wanted to analyze the problem in a beautiful way. He has taken AB, he has taken this section of the rod is like AC, and he has just said that you take perfectly 120 degree, you take C point here, just move it down there, it is 120, it is 60, 60, you are done with the solution. What I was trying to explain was the concept that could be beautifully used in this problem. Here the question has been taken up without any min-max statement. He has not said anything as such. So this question maker has directly said, fine, this was the orientation of the rod. After the impact happens, I will move 120, and at the 120 impact, I will have a hit here and I'll come back. So if you have to just solve the problem, I will get the answer through this. That's not a problem. But just think that IT can beautifully convert this problem. Like here it was 30. I think most of you must have got the answer. That was very straightforward. Because only thing is, you balance the time period, it is 2u sine 30 upon g. G was given as 10. That time is 1, because it takes, like, you understand, the collision happens there. You take that time as 1, you get your value of u, and accordingly everything can be calculated. Velocity at the highest point. So if I have to just solve the question, fifth question, at the highest point is u cos 30. U value can be calculated from there. You get your fifth question. And sixth, what was that? Length of the bar was required. So length can be, if I take it as L, this is L by 2, this is L by 2 cos 60. So I should say L by 2 cos 60, the twice. That will be equal to range. And that is u square sine 2 theta, that is 2 into 30 degree divided by g. I'll get my answers to the problem. Just think about what I have said, and you can formulate a wonderful combination. So consecutive is something that they have presumed just for the sake of the problem. Chalo, I think you understood the idea that I wanted to discuss on the previous page. That's why I was looking into the options. Next problem. In paper 1, any other problem coming to you? So should we move to paper 2 now? Okay. Let's go to paper 2. Any concern in paper 2?
First one.
First question. This is based on, if you observe the concept of a torsional pendulum, it was something which was similar to a torsional pendulum. Because if you take two threads which are oriented at some, there's a uniformly massed rod, these are the vertical threads. With respect to the central line, you just try to rotate it differentially. So what will happen is, like, both the ends will move marginally upwards. And once you know the expression of the movement of center of mass for the central point of the rod marginally upwards, you can solve the problem. So the thing was simple. So what you have to do, take the vertical threads, rotate the vertical threads by some angle theta. And while that rotation happens, you look into the rod and rotate the rod horizontally, right, by some angle alpha. Take care of this thing that thetas, alphas, they're all small angles, so that I can take the relations properly. Now what we are trying to say is that vertical movement which has happened because of theta movement, you can observe that is A into 1 minus cos theta. You understand this? Like, if this was L. I'm just showing one edge. And we know that while the movement happens, with respect to the vertical, it somehow moves to a new position at theta. So I've just taken the vertical projection L minus L cos theta just to write that. And simultaneously, there is some structure here which has rotated like this by a small angle alpha, right? So what are the lengths of those guys? That horizontal rod is of length L, so this is B by 2. So I should finally also say that B by 2 into alpha is L into theta. What is that L? That he has taken as A. Write that as A into theta. And as far as the displacement is concerned, now you can write this equation as simply like 1 minus 2 sine square theta by 2, and you will get your result. This is 2A theta square by 4. This comes out as A theta square upon 2. So that was the vertical movement of that point, and that was the second equation which we can write. Now observe both the relations carefully. The vertical movement that you have observed for the end of the rod, you just look into the structure, you'll enjoy the problem. The vertical movement of that end or the ends or the center of mass, that term for me is A by 2 into theta square, where theta is B alpha by 2A the whole square. B alpha by 2A the whole square, right? And effectively this comes out as, this is B square alpha square upon 8A. Alpha is the differential angle about the center that has been rotated here. And this was the original orientation, which has also gone to a new orientation somewhere here. And you understand that this orientation also forms an angle of theta in the opposite direction. And this angle is again alpha. This is B by 2. I'm talking about this and this. I'm talking about this. Now it was simple because once you understand that if something is being rotated for a differential time interval, you can assume the angular acceleration to be constant, right? So if you have got a relation for alpha square, this term can be written as, because you have given it an impulse of omega for a dt time, you can write this term as omega dt the whole square. So basically, what is the term that we are getting? We are getting B square by 8A into omega square into dt the whole square, and write this as half of B square by 4A omega square dt the whole square. And then say for a dt interval, doesn't it seem like that the displacement is half of some constant acceleration into time square, and then write your constant acceleration of center of mass of the rod, just B square omega square by 4. So that was the first part. What are the answers which are given? Out of C and A and B, if I read, delta y I can find out, which is B square by 8A omega square dt square. A option is correct, B is incorrect. For C and D, let me think now. What is delta F? He is saying what is the increment in the tension force. So we can write it simply. You know that initially whatever tension was there, that was balanced by the weight. So whatever acceleration you are attaining for the center point of the rod, that is because of the additional tension in both the strings in net. So just multiply this acceleration B square omega square by 4A into the total mass of the rod. So I think if you got this B square omega square by 4A, multiply this by mass of the rod. And you can check that out of C and D, C option is coming out correct. So you get your answer. Basically, that 3D structure was important, helical structure, then you will get your answer. So differential displacement, angular term omega dt for that angle. Thus equated it with half AD square because U was equal to Z. Simple. Next problem that comes to your mind.
So 7th and 8th.
7th and 8th. 7th is an interesting concept. I will directly tell you a short method. If this is a wall and this is a pressure pulse, which is given a shape, and this distance is 80 meters. And here, if I just draw it properly, this is 100 meter and this distance was 50. And the pressure pulse ka jo highest pressure tha, that was 100 pascals. The first question was, what is the time interval for which the wall detects the pulse? And the condition was that the wall detects the pulse if the peak pressure is 100 Pascal. So the matter of fact is, it's like a antinode for pressure pulse. Observe this thing carefully. So whatever pressure reaches there, then it will magnify there, and he has given you that it magnifies twice. So basically, if a pressure of 50 Pascal reaches this point, so when this pulse will move rightward, the first time 50 Pascal will reach here, it will become 100 by reflection, and then an instrument which is measuring pressure here will detect it. And it will keep on detecting it till the reaching pressure there lies between 50 and 100. Okay. So then he will detect everything which is greater than 100. That's what the condition is. But in this case, he has given a different value. He says a detector can detect a 16 Pascal. So you don't need 50, you need only 8 Pascal. Just take 8. Because if 8 reaches here, it will get converted into 16, and 16 he will detect. Now the simple question is, for 8 Pascal on the pressure pulse, can we find out this length? So when we calculated on the left hand side of the triangle 100, 100, so 8, 8, so this length is 8 meter, and there the length comes out as 4 because the base was 50, 100, so 4 will become 8. So out of this 150 meter spread of the pressure pulse, we are only interested in 150 minus 12 meters. We are only interested in 150 minus 12. This is the length. And while this pulse will be reaching, the pace with which the pulse is moving forward, that is given to you. That velocity, I hope, is 400 meters per second. 400 meters per second. So my answer to 7th question should be 150 minus 12 upon the pace, which is 400. If you solve this value, it comes out as 34.5 into 10 raised to the power minus 2 seconds. What I am trying to say is, he is observing 16. So basically, I need to impart or bombard 8. So till I keep on bombarding anything which is greater than 8, my purpose will be solved by the detector. So the first instance when 8 reaches, I'm not interested in the time instance when it reaches, I'm interested in the intermediate time interval. So I just calculated the length of the pulse where the pressure is greater than equal to 8. And that length I got by simple geometry. And then I divided by velocity with which it is traveling. I got the intermediate time interval. And second part of the question was simple. He said, what is the maximum force? So that is maximum pressure, P max, multiplied by the area of the wall. And area was 2 meter by 2 meter. And maximum pressure will be, maximum that reaches is 100 and becomes twice. So basically 100 into 2 is P max. So it comes out as 200 into 4. So that is 800 should be the correct answer. So that was the question. Right, next.
Second one.
Second. Okay. Second was again an interesting problem. It was something like this, that there is a wall, a ceiling, where there is a loose thread, right? A slackened thread. And from the highest point, there is a bead which has been dropped. This distance is A, and the length of this thread is 2A. And the question was, if the bead is allowed to fall, find the height H when the string becomes taut. So we will let this bead fall vertically, because till it becomes taut, nothing will happen. There will be an instance when this length and this distance, the total length exactly becomes equal to 2A. That is where it becomes taut. So if I assume this as X, this as Y, I'm searching for a X plus Y, which is equal to 2A, right? And I also know that root of Y square minus A square is also equal to X square. So all these equations, you got X and Y. That was the first part of the question. So what are the values that we got? We got 3A by 4 and 5A by 4. So X is 3A by 4 and Y is 5A by 4. So basically, you got the angles in the triangle. This was 90. What was the angle we'll get here? X was 3. So like this is 37 and this is 53. Just check this thing first. X by Y was 3 by 5. So that was fine. 37, 53. Now let us look into the main part of the question. So first part of the question, out of A, B, C, D, C is not possible. D, this distance which I am calling as X is calling as H. So that is 3A by 4. That is fine. Now, and the point is, when it becomes taut, right, at that instance, just after that instance, what is the speed of the bob? That is the question. Now, how do I observe this? I look into the problem like impulse. At the instance when it reaches here, there will be two striking impulses provided by these two guys, T. So the net impulse will be along the bisector, that is 26.5, 26.5. And the net impulse is along the bisector. The direction which is normal to this, in this direction, the velocity cannot change or momentum cannot change. So just resolve your velocity. So before the strings become taut, the velocity is u, and let's say that u is root of 2gh. So basically, I'll just find out this component afterwards. So I have to just find out the angle. Now I can say with respect to this, this is normal. So with respect to this normal, this angle will be 26.5. So simple idea was just resolve it. It is u cos of 26.5. That should give you the correct answer. Where u is root of 2g into h, and h was equal to or x, it was 3a by 4. That should be the result. If you just let me tell you one thing. There's an assumption that the question paper setter has taken, that the coefficient of restitution of the threads while they become taut is 0. So basically, along this normal, you can say, along that normal, he has presumed that whatever component of velocity was there, after getting taut, that has been lost, which is a general supposition for any thread. Until and unless IIT provides you E of the thread, then we have to take the collision as an oblique collision. I mean, you got the point. But if nothing is specified, we assume that the threads are tight generally, and we assume E to be equal to 0. So that component gets lost of that component of momentum, which was in this direction, that gets lost, and this momentum stays. So this is the result. And then if you solve, I think B option you were getting is not possible. Root of 1.5. Yeah. AGN. You should get just look into the angles there. If I have drawn the angles properly, because like velocity was here now. So with respect to this, I will take. So I should take cos of this 90 minus 26.5. So let me write 90 minus 26.5. Because my initial direction is here now. So I've taken cos of this. It will become sine. Rest is fine. Any other problem in paper 2? Idea, I think, is clear to all of you that my velocity is coming down, down, down as the strings become tight. At that very moment, there are two impulses by two strings. So I got the net impulse. mg cannot provide me considerable impulse in that dt time. That net impulse will change my momentum. So my momentum can change in this possible direction and not this. So I just resolved my momentum in this direction. I got my answer. Resolution of momentum is resolution of velocity basically. And what about this momentum? So I said I'm taking E as 0. So whatever initial momentum was present in this direction, that has been completely absorbed or lost. So that is how you'll solve the problem. Any other problem you are having?
Sir, 18th.
8th?
18th.
18th. Okay. Let me take. This was nice. I mean, very beautifully made problem. 18th. I loved it. I mean, conceptually, what he said is right, but he made a good geometry. Like he said, this is a semicircular arc and everything. Then he said in the initial state, let me just draw the initial state. It was like the level of the center here and this level was same. So it was a static state for the liquid. That was the equilibrium state. Then he said that find out the time period of oscillations. So I said if this is the initial state and liquid is being disturbed gradually by a distance of x here, it will move along the arc by a distance of x, and this will be a general state. So I simply thought that what I should do at the bottommost point, if I take a differential molecule, I'll try to find out the restoring force, like a restoring pressure on the system in the yellow state and multiply by the cross-sectional area. So restoring force general position mod should be an area into a restoring pressure here. So I thought what is going to happen is this line was at an angle of 30. So this side was x sine 30 x by 2. And what about this? This guy moved the distance of x. So there was some theta with which it moved. If you write the pressure here, you have to look into the height difference of this cross section and this cross section, right? So basically, what was this? This was x sine theta. So it is rho g into x by 2 plus x sine theta there. That term will come, x sine theta, right? That is the vertical displacement. So if you just presume that like those thetas are small, you should get your expression, because then I can write that term as simply this complete term in the vertical direction as x r theta. And that's what we can say. So it becomes r theta. And then theta can be written as x by r. You distinct that theta here is x by r. Right? So I think you got this idea that the difference that I'm getting now, if I directly write it, simply this term can be eliminated. And I could have directly said it is rho g into x by 2 term. That is the first term. And the second term that I'm getting is, it is rho g r into x by r. So I'm getting r into x by r theta term. Basically this vertical height. So if this is r theta I have written. The theta is x by r. And now I just took x outside. It is a rho g into 1 by 2 plus that term will come out as 1. So 1 into x. And now this coefficient is important. You got why I'm not getting minus, because I've written the mod. So I think time period should be written as, just observe, 2 pi root of this mass of this system upon this constant. So this constant is a rho g into 3 by 2. The mass of system is density into area of cross section into length. Now just try to write the length carefully. What is that coming out as? Here it was at the same level as r, and this angle was 30. So this is r, this length was initially 2r, and that arc length was 2 pi r by 4. So 2r plus 2 pi r by 4. Observe it. I think you'll get your answer. This expression will give you the answer. Rho a will cancel out, and now it matches with the pattern which is given. What I have tried to do here is, once I look into the geometry of the problem, my idea was simple. I thought this is a balanced system. I'll just try to displace it by a small x, push it by small x, and at that position on the complete system, what is the restoring force? So the best thing to feel the restoring force is think about some molecules which are at the bottom. There will be a excess pressure from this side, and there will be a less pressure from this side. So pressure difference into area of cross section will drive the system. So I just wrote the pressure difference. Which cross section I could have written anywhere. But writing at bottom is simple way of feeling it. I could have written it anyway. Simply between these two levels also you can write. That's simple. Any other problem? I think all of you are done with this discussion. So then, if it is done, that's fine. If there is any conceptual point, I can just discuss it like this before I leave. If you want anything in the paper, or we will leave and I'll see you in the class afterwards.